At the very top of this, please write sum or difference of cubes. That's the title of this lesson, sum or difference of cubes. Then I would like, just like yesterday, I'd like you to take a highlighter out. You can share it with somebody in your group if you don't have one. And please highlight these perfect cubes. This is something I do want you to have memorized. Please no talking right now. We don't have extra time today. You're welcome to share a highlighter with somebody else. You won't have to use it again. We're going to get started right now in example number 1. Again, I'm going to ask that it's quiet. Example number 1, in front of the A right now is a hidden 1. Now each one of these portions can be broken apart into 3 equal pieces. How do I achieve 1? 1 times 1 times 1. A cubed is A times A times A. 27 is 3 times 3 times 3. When that is possible, we are able to find the sum or difference of cubes. It will always be in this form. There's going to be 2 parts followed by 3 parts every single time. This last sign will always, always, always be positive. To determine the signs of the other 2 positions, the first sign is going to be taken from the original expression, and then this position will be opposite of the first. All right, so 1 and A come from the front. 1 and A come from the front, so I put a 1A in front and then I cross it out. And 3 comes from the back, so I put a 3 in back. In the second parentheses, I have 2 1s left. 1 times 1 is 1. A times A is A squared. They come from front, they remain in the front. 3 times 3 is 9. It comes from the back and it remains in the back. How do we get the middle term? Forget about positives and negatives. We're only going to multiply here. 1A times 3 is 3A. This is equivalent to this expression. It's the factored form. They are equivalent expressions. Example number 2. Remember, after each example, you're going to put a star in the box if you feel confident you could do it on your own. And you could do it within a certain amount of time. If you need to review it, put a big circle around it. Okay, please look back at the highlighted portion. Is 5, 12, and 1 in that list? 5, 12, and 1. Okay, we can do this. So 5, 12 is going to break into 8 times 8 times 8. 8, 8, 8, B, 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 and 1, 1, 1. This is factorable. 2 in the front. My last parenthesis contains 3. This will always be positive. How do I get the signs from the other 2 places? Well, it's positive in the original, so it's plus here. This is opposite, which is going to be negative. From the front, I take an 8B, and the back, I take a 1. Okay, in the front, I have 2 8s left. 8 times 8 is 64. 2 B's. B times B is B squared. In the back, 1 times 1 is 1. Okay, in the middle, forget about signs. 8B times 1 is 8B. There's the answer. This is rewritten in factor form. They are equivalent expressions. Going to number 3. Is 64 on the list? Is 216 on the list? What is 64? Go find it for me. What is it? So 4, 4, 4, C, C, C. And what is 216? 6, 6, 6. Ooh. So 2 in the first parentheses, and your final parenthesis always contains 3. The last sign is going to be always positive. Okay, this problem was negative, so negative's in front, and opposite would be positive second. Take one of the 4's and one of the C's. They come from the front, they stay in front. 6 comes from the back, it remains in back. Second parentheses, 4 C's come from the front, they remain in front. 4 times 4 is 16. C times C is C squared. 6 has come from the back, it remains in back. 6 times 6 is 36. How do I determine this middle term? 4C times 6 is 24C. Example number 4. Example number 4. The only difference with example number 4 is, can everybody see how the variable is now in the back? Everything else is the same. Find 343. Is it on the list? Is 27 on the list? 343, you can look up above, is 777, and 27 is 333. 2 always in the first, and 3 in the second parenthesis. So it always ends in a positive sign. This first sign comes from the original expression, and it's opposite as the first symbol in the second parentheses. Okay, so 7 comes from the front, it stays in front. 3D comes from the back, it remains in back. In the front, 7's come from the front, they stay in front. 7 times 7 is 49. 3 times 3 is 9. D times D is D squared. How do I achieve the middle number? Forget about signs. 7 times 3D is 21D. I also want you to write this down. Please write this down. This trinomial right here, okay, if you were asked to solve it, you would always, always, always have to use the quadratic formula. You can never take it a step further. It can never be reduced a step further. We're going to come back to that next chapter. Just keep that in mind. Okay, let's go on to the next one. Now this one, let's check. Is 8 on our list? Yeah. Is 125 on the list? Mm-hmm. Okay, I did make a mistake here. Can you please put, if you looked at the PowerPoint, it had a cube here. Can you please change that? Okay, so 8 breaks into 2, 2, 2, F, 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 and 5, 5, 5. I'm going to give you on your own 30 seconds to see if you can get the answer. Only look up at the screen when you are done to see if your answer matches mine. Okay, if you're not done, please copy down what I have. Please make sure that examples 1 through 5 all contain either a star or a large circle. Star means I understand it, I can do it in a quick amount of time. A circle means I need to review it tonight before tomorrow's checkpoint quiz. I'm moving on to example number 6. Now, this looks slightly different, and here's the reason why. Is 32 on the list? Okay, I'm going to slow it down. Pay close attention. So, 32 is right here. It's right above the 27. So I'm going to examine all the numbers that are underneath 32. I know that 1 nicely divides into 32, but it won't reduce anything. So of the numbers that are below 32 and highlighted, which one nicely divides, if any, into 32? 8 does, right? Okay. 8 times what number is 32? Put a 4 up front. 4 times 8 is 32. Attach the G cubed. Now grab your calculator and take 108 and divide it by 4. 108 divided by 4 is an answer of 27. Is 27 on the list? Okay, since 8 and 27 are on the list and we have G cubed, this would be 2, 2, 2, G, 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 and 3, 3, 3. Two G stays in front. 3 is from the back, it stays in back. 2 times 2 is 4 with the G squared in front. The 3's come from the back, they remain in back. 3 times 3 is 9. How do I achieve the answer for the middle term? 2G times 3 is 6G. Please make sure you star or circle what you need to review. Star or circle. Okay, here's number 7. Please change number 7 to make the 150 an actual 250. Okay, here we go. So I want to take out here, I'm looking at the -2 and I go, okay, forget about it being negative. Where does 2 land? Okay, 2 is right here. And how can I turn 2 into a 1? All right, well, if I pull out a -2, let's try that. Let's pull out a -2. -2 times what would give you a -2? -2 times 1. Attach the h cubed. -2 times what quantity would be a positive 250? -125. Now, how can you do that? Take 250 and divide it by the factor out front, which is -2, which you're factoring out. The answer is -125. Is 1 on the highlighted list? Is 125 on the highlighted list? 1, 1, 1, H, 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 and 5, 5, 5. 2 terms in the first parentheses, 3 terms in the second. Now, here's where it's confusing to students. How do I know what goes here? We're referring back to the parentheses. This is what we're referring to. So it has subtraction right in this position, so subtraction goes here, and it's opposite in the next one. I'm taking a 1 and an H and placing it in front. Comes from the front and stays in the front, and a 5 in the back. 1 times 1 is 1, with an H squared in front. 5 times 5 is 25. The middle term, forget about positives and negatives. 1H times 5 is 5H. Please make sure to star or circle, and then we'll move on to the next. All right, so here we go. This is a little more confusing. Do you see 3 on the list? Can you do me a favor? Type in 2,187 and divide it by 3 and see if that number's on the list. Could I factor out a 3? Is 729 on the list? Sure is. Okay, so not only am I going to take out a 3, both the front and the back have at least 1 J. There's 1 J here and 4 in back. So the most I can take out of both the front and back is 1 J. In parentheses, 1 J times what quantity is 1 J? I'm saying it wrong. 3 J times what quantity is 3 J? 1. And 3 times 729 is 2,187. I want to end up with 4 J's. Once I distribute, I only have 1, so I need to attach 3 more. How do you determine if you can move forward? Is 1 and 729 on the list? Okay, so 1, 1, 1, 9, 9, 9, and 3 J is broken up. Okay, so I'm referring back to this parentheses for symbols. This is always positive. This was negative in between, and opposite of negative is positive. Bringing down 1, 1 in front and 9J in back. In front, 1 times 1 is 1. In back, 9 times 9 is 81 with the J squared. And for the middle term, 1 times 9J is 9J. Okay, again, please make sure that you are starring or circling based on your understanding. We're going to go on to example number 9. Example number 9. Okay, so 375. Okay, please look at the list. I'm finding 375, which is right here, and I'm going to examine the numbers that are below 375. What is the largest number that nicely divides into 375? So I take out the calculator, knowing that 375 would occur after 343. And I can see that 343 does not nicely divide into 375. Likewise, 216 does not divide in. But I do know that 125 divides in a total of 3 times. So let's go back to this problem, and let's put a 3 out front. Just like example number 8, they both contain k's. What's the most k's I can take out of both? Now, inside parentheses, if you distributed the 3k, you'd end up with 3 times 125 is 375. You need 1k. When you distribute, you already have it. Bring down the subtraction sign. Can you please take 192 and divide it by 3? The answer is? So 64. 3 times 64 is 192. I need 4 k's. I have 1. I need to attach 3 more to equal 4 k's. Is 125 and 64 both on the list? So this would be 5, 5, 5. 3, 3. Is it 4, 4, 4? And K, K, K. That doesn't sound good. I got to change that letter. All right. 2 terms in the first parentheses. The second parentheses will contain 3. This is always positive. We have subtraction here and opposite second. Bring down 1, 5. It comes from the front. It remains in the front. Bring down a 4k for the back. 5 times 5 comes from the front. It remains in front. 4 times 4 is 16. K times k is k squared. Comes from the back, remains in the back. How do I get the middle term? 5 times 4k is 20k. Please, less talking and back. Go on to example number 10, please. Example number 10. $32. Please go back to your list and find 32. 27, 32 would occur right here. Does 27 nicely divide into 32? No. Does 8 divide in? So what number times 8 is 32? So put a 4 out front. We're going to slow down this one a little bit more. Okay. So I have 3 m's, but they don't both contain an m, so I can't take m's out. But they do both contain n's. What's the most I can take out of the front and the back? 4 times 8 is 32. I need 3 m's, so I attach it, and 1 n, which I already have. Bring down the symbol. 4 times 1 is 4. I need 4 n's. I only have 1. Attach 3 more. Underneath the 8, we're going to do 2, 2, 2, m, m, m. Underneath the 1, 1, 1, 1, and n, n, n. All right, so we can move forward. Remember, first parenthesis contains 2, second parenthesis contains 3. Okay, so in the front, 2 m's come from the front, so 2m in front. I should have put down the symbols. So 2m comes from the front, 1n comes from the back. Back to the front, 2 times 2 is 4, m times m is m squared. In the back, 1 times 1 is 1, and n times n is n squared. In the middle, 2m times 1n. Well, I know 2 times 1 is 2, and m I'm going to push together. And we generally write them in alphabetical order, so m before n. Let's go on to example number 11. Example number 11. What number is in front of the P? And what about the Q? So this is 1, 1, 1, P, 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 1, 1, 1, Q, Q, Q. Okay, you have 45 seconds to see what you can do. Go ahead, please. Look up when you're done to see if it matches my answer. Can I have a thumbs up or thumbs down based on your understanding of that problem so I can see? Majority of us are thumbs up or to the side. Okay, let's go to the next one. What number is in front of the R? Okay, is 1 and 27 both on the list? Okay, now this is one that's just like a little bit trickier in how we do this. This is a little bit trickier, and we got to see, is this possible? Is this possible? You ready? So this is 1, 1, 1. Now, how would I do the 6? How do I break up the 6 evenly among 3? Squared, squared, squared. Now, I am guessing I meant this to be a 15. So can everybody change this to a 15? How do I break up s to the 15th into 3 equal ones? 5, 5, 5 for the exponents on the s. And what does the 27 turn into? 2 in the front and 3 in the back. Subtraction sign to start with, and then opposite and always positive. 1r squared in front, because I'm taking one of both of these, and the back 3s to the 5th. Okay, let's slow this down. 1 times 1 is 1. That's not too hard. But what is r squared and r squared? If you forgot how to work with exponents, when you have the same base and you're multiplying, you add the exponent. So how many r's do I actually have here? R to the 4th. Likewise, 3 times 3 is 9, and this would be s to the 10th. The middle term is achieved by multiplying these two. 1 times 3 is 3. And I'm going to write them in alphabetical order. R squared, x to the 5th. Please make sure you have circles or stars next to every problem. Let's go on to example 13. 8 breaks into 2, 2, 2. And t to the 6th breaks into t squared, and t squared. 125 breaks into 5, 5, 5, and let's change this up. Let's make the 16 into an 18. And so it becomes u to the, anybody want to share? U to the 6th. So it's going to be a negative, then opposite, and always positive. I bring down a 2t squared in front, and back a 5u to the 6th. In front, 2 times 2 is 4, and now when you multiply, you add the exponents, so t to the 4th. And back, 5 times 5 is 25, and you add the exponents when you have the same base, and you're multiplying, so u to the 12th. How do I find that middle term? 2 times 5 is 10. We write them in alphabetical order, so t comes first. T squared, u to the 6th. We can't add these exponents because we have a different base. Let's go to your last one of the day. Very last one of the day. Change this number here for me, please. I'd like to switch these up. Can everybody find the 6 for me? Everybody find the 6. I'd like you to make this a 9. Find the 16 for me, and I'd like you to make it a 21. I'd like you to do this within your group, then check your answer with mine when you're done. Begin.